All right, this is lesson 722, the second lesson in chapter 7. We are going to explore the properties of a rhombus. So in last lesson, we learned about parallelograms and kites. A rhombus is another form of a parallelogram, but in this shape, it has 4 congruent sides. So that is what it is defined as. Rhombus is a quadrilateral with 4 equal sides. All right, so we are going to draw a rhombus like the one below on your paper. So if you don't have these notes, then you can draw that on your own paper. Mark the side lengths equal. So I know that this one doesn't look equal, but a lot of the shapes in here are not drawn to scale. All right, so we're going to use the tick marks to show that those sides are equal. What else might be special about the sides of a rhombus? Well, let's see. They could be parallel. So maybe we want to prove that opposite sides are parallel to each other. Maybe we want to prove that opposite angles are congruent to each other. These are all properties of a rhombus. So this is just one property. A second property could be that opposite angles are congruent. A third property could be that opposite sides are parallel. All right. Let's see. So I think in this lesson, I proved that the opposite sides were parallel. And so we're going to start that proof by writing down what we know. Before we do that, we need to add a diagonal PR. So add a diagonal from P to R. Oh, that's not very good, but here, let me try again. A little bit better. All right, so diagonal PR, and that makes it 2 triangles that should be congruent. And so we're going to prove that these 2 triangles are congruent, and then we can prove that if we improve alternate interior angles are equal, then that means that opposite sides are parallel. All right, so we know that these 4 sides are equal to each other, so I'm going to put that in my proof. PQ is equal to QR, which is equal to SR, which is also equal to PS. And we know this, remember we want to put our justifications underneath now. We know this because that's the definition of a rhombus, 4 equal sides. All right, the only other part that we need to prove that our 2 triangles are congruent is that PR is equal to itself. So we can say that PR is equal to PR. And that reason for something equal to itself is, that's right, reflexive property. All right, so now we can say that our 2 triangles are congruent to each other. So triangle PQR is congruent to triangle PSR. We draw our arrows, and our justification is that side, side, side theorem. 3 sides in a triangle are congruent, then those 2 triangles are congruent to each other. And then finally, we can say that those alternate interior angles are congruent. So this angle is equal to this angle is equal to that other angle. All right, so we're going to say angle P, or angle QPR, oops, is equal to angle SRP. We know that by CPCTC. I'm going to write down what that means in just a second. So that proves that our opposite sides are parallel because we have alternate and interior angles equal. All right. So what does CPCTC even mean? CPCTC stands for corresponding parts of congruent triangles are congruent. So first letters of that phrase. For example, if we know that triangle ABC is congruent to triangle DEF, then we know that all of their angles and all of their sides are congruent. So just based on the order of the letters, we know that angle A is equal to angle D, B is congruent to E, and angle C is congruent to angle F. We also know based on the order of letters, line or side AB is congruent to side DE, BC and EF, and then AC and DF. All right, so we're also going to prove that diagonals bisect each other in a rhombus. All right, so this is basically asking what do we think is true about the diagonals SQ to PR. So we are going to prove that ST is equal to QT and that PT is equal to RT. Remember, that's what bisect means, cuts it into two equal halves. All right, so a conjecture is if I were to just write an if-then statement. So my statement could be if we have a rhombus, then the rhombus diagonals are bisected. Write a flowchart proof that proves your conjecture from part B. Remember that to be convincing, you need to justify each statement with a reason. All right, so the triangles that we are going to use are going to be the top and the bottom triangles. We just can't pick the triangles that are side by side because they are missing out on at least one of the other diagonals. So I'm going to redraw just two of these below. All right, so I chose P, Q, T, and S, R. All right, so first of all, what we know is that the sides in a rhombus are all equal to each other. So then I know that the top side is equal to the bottom side. So I can say that PQ equals SR. And that I know by the definition of a rhombus. All right, and next, I'm going to use some angles. So what I'm going to do is use like angle, angle, side, or angle, side, angle. I know that the alternate interior angles are equal. Since I know that these sides are parallel. All right, so I'm going to write that here, kind of over here. I kind of don't have a ton of room. So just as a side note, I'm going to put PQ is parallel to SR. And we know that because that's a property of a rhombus. And so then I can say that angle P is congruent to angle R and angle S is congruent to angle Q. Circle that. I'm going to kind of draw an arrow because we know those are congruent because lines are parallel. So, and those are alternate interior angles. So we have parallel lines, we know that alternate interior angles are congruent. So that helps me prove that the triangles are equal. So triangle PQT is congruent to triangle RST by angle, side, angle. All right, and if we know that those two triangles are congruent, then we can say that all the sides are congruent to each other. So now we can say that ST equals TQ, or QT. And that PT equals RT. And we know that because corresponding parts of congruent triangles are congruent.